Our next lesson is called 4 Interesting Transformations of Functions, and we're going to use this for days 1 and day 2. So we're going to start with an example. I need you to make sure that you have 3 different colors that you can use when creating this graph. So either 3 different colored pencils or a pencil and 2 other colored pencils so that you can make nice, neat pictures that is easy to read, okay? So if you need to pause the video and go grab those materials, please do so now. All right, example 1 says, let f of x equal the absolute value of x, g of x is equal to f of x minus 3, h of x is equal to f of x plus 2 for any real number x. So the first thing they'd like us to do is write an explicit formula for g of x in terms of absolute value. So let's talk a little bit about what that top notation looks like. When I see that f of x is equal to the absolute value of x, that's called our parent function. So actually down here in the table of values, I want you to put an arrow and write that this is called your parent function, meaning the starting point. They are telling you that f of x is equal to the absolute value of x. So when you see g of x and h of x using that, this absolute value of x is going to go in this spot, and it's also going to go in this spot. So the idea here is that you replace f of x with whatever it's equal to. So in our situation, we're replacing it with the absolute value of x. So we're going to write an explicit formula for g of x in terms of absolute value, which means without using the f of x notation. So we start out with g of x equaling f of x minus 3, but that's going to change into g of x, and where the f of x used to be, we're going to replace it with what f of x equals, which is the absolute value of x, and then minus 3. So this would be the explicit formula for g of x. Then, in part B, write an explicit formula for h of x in terms of the absolute value of x without using f of x notation. So again, we started out with h of x being equal to f of x plus 2, but that's going to change into h of x equaling, in f of x's spot, we will replace it with what f of x equals, which is the absolute value of x, and then plus 2. So now it says complete a table of values and graph for these functions. So I'm going to color code them as you see them up top. H of x will be in pink, g of x will be in teal, and our parent function will be in green. You need to have your graphing calculator. Go ahead and get that ready, and I will show you how you can use your graphing calculator to help you complete this. Okay, now that we're at the graphing calculator, you can actually enter all 3 of these functions at the same time. So to get the absolute value symbol, you hit math. You're going to hit right over to number and pick choice 1 for absolute value. This one is just the absolute value of x. You can arrow over to the right and then hit enter. The next one, if you recall, was g of x, taking f of x and minusing 3. So the absolute value of x minus 3. So math, over to number, pick choice 1. In this, you should have an x. Use your arrow to the right to get out of the absolute value, and then you're going to type minus 3. Then going down again, we need the absolute value of x. So math, over to number, pick choice 1, type in your x, go outside of the absolute value with your arrow, and type plus 2. So now we can graph this by using Zoom Standard, which is choice 6, and we can get an idea of what our pictures are going to look like. And then specifically, we want to go look at the table, so we're going to hit second, graph, and it takes us to a table of values. We are starting our table up here at -3. So you want to take time to copy this table into your notes. For time purposes, and since this is a lesson we're doing together, now that you see where I'm getting the information from, we'll just quickly fill in the tables together in our notes. So my table for f of x equals the absolute value of x, which is our parent function, is 3, 2, 1, 0, 1, 2, 3. You're going to notice that absolute value pattern that we've discussed in previous lessons. You could do this by hand, saying to yourself, okay, -3 goes in for x, the absolute value of -3 is 3. But the graphing calculator will do all of that work for you. Then for g of x, we have 0, -1, -2, -3, -2, -1, and 0. And lastly, for h of x, we have 5, 4, 3, 2, 3, 4, and 5. Now, if we actually take a look at this, do you notice that f of x equals the absolute value of x for -3 was 3? And then when we subtracted 3, it actually went down 3. And when we added 2, it actually went up 2 from 3. So we'll talk more a little bit about that, but I wanted to point that out as we see it here in the table. So now we need to create a picture of all of these functions. So we'll go back to the parent function and do that one first. So it's going to continue in that pattern of having a slope of -1 and a slope of +1. Please use rulers to make your graphs as accurate as possible. And when you're done, the way that you label this is by saying y equals f of x. If you were to label it with just f of x, I would also take it. Okay, now we'll graph g of x. So -3, 0, -2, -1, -1, -2, 0, -3, and that's our turning point where we head back up. Again, follow that slope and use your ruler so you have nice straight lines. Arrows on both ends, and make sure you label. So this is y equals g of x. And then lastly, we will graph h of x, -3, 5, -2, 4, -1, 3, 0, 2. That's our turning point where we go back up on the other side. We're going to create this graph, again, very neatly and carefully. Arrows on both ends. This is going to be labeled with y equals h of x. So now we have the same picture that we saw in our graphing calculator. So up next, what is the relationship between the graph of y equals f of x and the graph of y equals f of x plus k? So that's referring to the change between green, in my picture, the parent function, and then plus would be h of x, where we added a number on the end. So what happens when we went from green to pink? Well, if I look at my picture, the green function has translated up vertically. So when k is greater than 0, so in other words, you're adding, okay? So we'll say adding to y. The points translate, because it's a slide, up vertically. Now, if we were adding k and we were to make this a number that's less than 0, then that would mean it's taking us to the teal. So that would be looking at the green to the teal and seeing that that actually translated the function down. So when k is less than 0, or in other words, we are subtracting from y, the points translate down vertically. So if I add a number, it goes up. If I subtract a number on the outside, it goes down. In part E, how do the values of G and H relate to the values of F? So I kind of alluded to this earlier when we were looking at the table of values. But if you look at the original F of X and then you look at G of X, all of the output values have gone down by 3 because there was a subtraction of 3 on the outside of F of X. Okay, so if we look at G of X, it is 3 less than F of X. If we look at H of X compared to F of X, 3 went to 5, 2 went to 4, 1 went to 3, you can see that they are 2 more. So H of X is 2 more than F of X. Now, when we're talking about 3 less, 2 more, we're talking about the range or the Y values. So underneath that, please put with a star, very important, that we have the same domain. It's not our X values that are changing, okay? So same domain. And then you're going to put a second star and say this is a shift in the range, which remember means Y values. Okay, and this concludes your example for 4 interesting transformations of functions day 1. You will now be working on investigation 1 on the next page.